Okay, in this video I'm going to talk about the bisectors of the angles between the opposite sides of a cyclic quadrilateral and the fact that they're perpendicular to each other. So basically we have a quadrilateral, something like this. And we consider the angles between the opposite sides. So we extend the sides until their intersections. So here and yeah, so let me draw it a little more further. Yeah, so we have so this is the original quadrilateral, would be A, B, C, D. So we extend the opposite sides until their intersections, and now we consider the bisectors of these angles. So the bisector here, such that these angles are equal to each other, and the bisector here, such that these angles are equal to each other. And basically the theorem is that, so like we are interested in the angles between in the angle between these two bisectors, and the theorem is that if the original quadrilateral is cyclic, then this angle is a right angle, so they're perpendicular. So if the cyclic, it means that it's inscribed in a circle. So like there is a circle that passes through all four vertices. So if there is a circle passes like this through all four vertices of the original quadrilateral, then this is a right angle. So let's write this. So theorem. So let's write this. So ABCD is cyclic. It implies that the angles it implies that let's this point be P, and let's this be P and Q, and this intersection point is denoted by R. So then this implies that PR is perpendicular to QR. Okay. So let's prove this. So we are going to use two theorems about the angles. In a circle. So like if we have a circle and the angle between two chords, then it can be expressed as half of the sum of these two. So if this arc is alpha and this arc is beta and this angle is gamma, then gamma is equal to 1/2 of alpha plus beta. So half of the sum of these arcs, that it's subtends. I'm not sure if you can say subtends for an angle like this, because usually subtends is applied for an inscribed angle, but yeah, like kind of the two arcs that are cut by this angle. And the second theorem is kind of similar, but when the lines intersect outside of the circle. So if we have basically an angle like this, angle gamma, and these two arcs are alpha and beta arcs in the circle, then gamma is equal to 1/2 of alpha minus beta. Yeah, so I made separate videos about these theorems. I proved it there, but here we are going to use these two theorems. So let's denote now so let's draw a new picture. So we have a circle. And we have just trying to fit it into the same okay. So A, B, C, D, and we have two bisectors here. So this is the bisector and this is the bisector. So let's denote all the arcs that our circle is divided into. So let's denote this alpha 1, alpha 2. This arc denote beta 1, this arc beta 2. This arc gamma 1, gamma 2. And this arc delta 1, and this is delta 2. Okay, and so what we need to find is this angle, basically. Right? We need to prove that this is 90 degrees, that this is a right angle. But so this can be calculated as half of the sum of these two arcs, right? So it can be, so let's denote this angle as x. This is the desired angle that we need to find. So this angle x is equal to 1/2, like using the theorem that I gave above. So this is 1/2 of the arc so beta 2 plus gamma 1. So we don't have this letter here, so I will write just beta 2 plus gamma 1 plus this arc, this and this. So plus alpha 1 plus delta 2. So that's what we need to find, to prove that it is 90 degrees. And because of the bisectors, we know that so this angle is equal to this angle. So this angle is equal to 1/2 of delta 2 minus beta 1. So delta 2 minus beta 1. So this angle. So if this is P and Q, right? So and this is R. So this is angle APR. APR is equal to this, and it should be equal to the angle DPR, and this is equal to 1/2 of delta 1 minus beta 2. Delta 1 minus beta 2. They must be equal to each other. So we have that delta 2 minus beta 1 is equal to delta 1 minus beta 2. And so this condition we obtained from the bisector, from the fact that these two angles are equal. And for the other bisector, that these two angles are equal, so the angle AQR can be expressed as half of alpha 1 minus minus gamma 2, the arcs that this angle cuts in the circle, and the angle BQR is equal to 1/2 of alpha 2 minus gamma 1. And from this we conclude that because these two angles are equal to each other, we conclude that alpha 1 minus gamma 2 is equal to alpha 2 minus gamma 1. Okay, so now we can sum these two equalities together. So from this and this, it follows that when we sum them together, let's write this carefully. So it follows that alpha delta 2 minus beta 1 plus alpha 1 minus gamma 2, this is the sum of the left hand sides, is equal to delta 1 minus beta 2 plus alpha 2 minus gamma 1, right? So now we can rewrite this. So just let's move all the letters with the minus sign to the right side, and so that there would be only pluses basically. Let's move them to the appropriate side of the equality. So it would be alpha 1 plus delta 2 plus alpha 1 plus beta 2 plus gamma 1 is equal to delta 1 plus alpha 2 plus beta 1 plus gamma 2. Okay, and now we recall that we have the angle x expressed like this, angle x that we need to find. And so this expression beta 2 plus gamma 1, so if you look carefully, so beta 2 plus gamma 1 plus alpha 2 plus beta 1. So this is actually exactly the expression on the left hand side here, just in different order. So beta 2, gamma 1, alpha 1, and delta 2, right? So this expression is exactly what we need. And now we need one more equality, is that the sum of all these arcs is the full circle. So basically like alpha 1 plus alpha 2 plus beta 1 plus beta 2 plus gamma 1 plus gamma 2 plus delta 1 plus delta 2. This is the full circle, which is 360 degrees. Right, so we notice simply that this, like in this equality that we obtained, like on the left hand side and on the right hand side we have all the angles that are in this equality. So if you denote this let's write it this way. So this can be rewritten as delta 2 plus alpha 1 plus beta 2 plus gamma 1 plus delta 1 plus alpha 2 plus beta 1 plus gamma 2, right? So these are two expressions on the left hand side and right hand side in this equality. So like if you denote it by, let's say, y, then this would be y and this would be y, right? And the sum of this is 360. So like 2y is equal to 360. Therefore y is equal to 180, right? So this is equal to 180. And so the left hand side, as I already mentioned, is the same as the expression for the angle x, and so the angle x can be expressed as 1/2 of 180, because the sum we just found, this is equal to 180. Yeah, so 1/2 of 180, this is simply 90 degrees. And this is exactly what we need. So x is equal to 90 degrees. So this angle x here is equal to 90 degrees. So this is a right angle. This means that PR is perpendicular to QR. And this concludes the proof.